An RC model enthusiast asked if he could build a remote-controlled airplane that is fast, has a long flight time, is simple, and durable, excluding the remote control with an excess baggage fee of 100 yuan. Asking how to construct such a remote-controlled aircraft, the answer is readily apparent. This is a copy of the US military's Spring Knife 300 drone, which is installed inside the launch tube. Igniting the launch charge propels it out, unfolding into an aircraft 50 centimeters long with a wingspan of 68 centimeters and weighing 1.8 kilograms. The motor in the tail drives a folding propeller capable of pushing it to cruise at 100 kilometers per hour for 15 minutes. Mounted on the fuselage's back is the flight control and GPS module, allowing it to fly autonomously on a preset route. The camera's video signal is transmitted using a 2-watt transmitter, and the ground-based FPV goggles can receive the transmission signal from up to 10 kilometers away. Simultaneously, it can lock onto the target image in the feed and relay it back to the drone. At this point, the flight controller will automatically unlock the fuselage to align with the target, then dive at a speed of 160 kilometers per hour, finally detonating the fuse with a radio signal, exploding the barrel of shaped explosives made of copper. The B explosive, formed by melting and mixing 90 grams of HMX and TNT inside, shatters the copper casing into a metal jet to penetrate the armor, thus capable of destroying light armored vehicles or bicycles, which is why the Switchblade 300 is called a cruise missile, but essentially it is just an FPV drone model. The reason for designing it as a tandem configuration is to ensure enough wing area and perfect folding while also using the aerodynamic traits of the tandem layout, because the wings create self-downwash and the vortex that passes over the gap between the wings. When this combines with the airflow coming from ahead, the actual air current originates from the upper front of the wing, causing the lift force to lean backward, resulting in induced drag. To reduce induced drag, the wing aspect ratio must be increased so its forewing is relatively slender and the rear wing's aspect ratio is shorter, causing the interwing vortex to move upwards. This perfectly cancels out the downward vortex from the forewing, forcibly reducing the induced drag on the aft wing. This allows the aft wing to be made wider and shorter, increasing the lift generating area. Although these two short wings still have slightly higher induced drag compared to the stacked long wings, having the span greatly enhances roll maneuverability. Furthermore, this wingspan is less than 70 centimeters, yet it weighs 1.8 kilograms. The canard configuration allows both the front and rear wings, which feature a semi-convex high-lift airfoil, to lift the center of gravity together, fully utilizing the lift-generating area. However, when the downwash from the forewing hits the aft wing, it reduces the angle of attack and weakens the lift of the aft wing. Therefore, compared to the stacked long wings, these two short wings result in a slight decrease in lift. Simultaneously, when the forewing moves down and lift increases, the downwash angle becomes larger, causing the lift of the aft wing to decrease synchronously, creating a significant nose-up divergence. Conversely, when the wing moves up and lift decreases, the upwash angle increases, causing the aft wing's lift to decrease simultaneously as well. This simultaneously increases a strong downward pitching moment, so the aircraft only needs two ailerons to deflect two wing sections to simultaneously increase or decrease the lift of the front and rear wings. This grants the heavy fuselage enough rolling moment, making the aircraft very agile. Thus, tandem wings are not equivalent to wings that are joined together. The total lift of the long tandem wing is smaller and total induced drag is greater, making the lift-to-drag ratio lower. 1 + 1 is less than 2. But this layout allows for a greater span. The shorter wing has a larger lift area and is lighter, compensating for the lift-to-drag ratio loss, allowing long flight with lower wing loading, and it is also very crash-resistant. So, using free polyvinyl chloride pipes and wooden pieces, I cobbled together a spring-loaded knife with a $300 casing, installing the XXD, the R21-2 motor and smoke generator set, connected to a second-hand lithium battery and two $10 ailerons, and finally, the inherited MC6 receiver was fitted inside. Then I can happily fly it hard and crash it.